Give me a second. I'm having some technical problems. Darn it. All right, I'll try to just fix that later. All right. So 3, number 15. And it's we're going to find a cross product of two sets. We're given a set A, and it has the elements B, A, T, and a set B, and it has the elements F, L, and Y. So, and it's going to ask us to find all the elements of A cross B. Now, before we start, an element of a cross product is an ordered pair. And before I even start the problem, I'll know how many ordered pairs I should come up with. The cardinality of cross product is equal to the product of the cardinalities. That is, how many ever elements there are in A times how many ever elements there are in B. So in this case, that would be 3 times 3. So I know I have to have 9 ordered pairs. All right, so here we go. And there's no, you don't have to have these ordered pairs in a particular order. We just have to have all the ordered pairs. So what I do just kind of systematically is I'll say, okay, I'll take B because in the ordered pair, the first component comes out of this set. Then the second component comes out of that set. So I'll just kind of go down the line, take this one, and then write the ordered pair BF. Then comma to separate the elements. So I've got my first ordered pair. Then I'll go BL. And that's better parenthesis. Okay. And then BY. Then I'll take A and do the same thing. So I'll have AF and then AL and then AY. And then 3 more TF, TL, and TY. Those brace. So what you have to do on my math lab is type these in. They give you the braces. You just have to supply in the ordered pairs and watch your notation, because there are a lot of parentheses there. You have the parentheses separating the components of each ordered pair, and then you have parentheses separating the ordered pairs themselves. So if you pretty much got the concept down and you've typed all 9 ordered pairs in, go back and check your parentheses. Unfortunately, the decimal point or period is right beside the parenthesis on the keyboard. And it is so easy to accidentally hit that decimal point button and just have one in there, and syntactically it's going to count it wrong just because of that one just because of that one decimal point in for a where there should have been a parenthesis or a comma, excuse me. So anyway, any questions on that? Now, it also asks you to find, on this problem, incidentally, B cross A. Now, once you have A cross B, all you need to do is go in and transpose every ordered pair. Simply, again, the first component comes out of this set and the second component comes out of that set. So it would be FB and LB and YB, FA and LA and YA and FT and LT and YT. Also note there are, for this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is these two sets are disjoint. They don't have any elements in common because these ordered pairs are not the same, but the cardinalities will always be the same. Any questions on that? Once, twice. All right. So page. I believe I'm having a little bit of technical difficulty. I saw chat come in. I can't even close my screen share here. Had a power outage here about 15 minutes before class. I don't know if that has anything to do with it or not. I believe it was number 19 I saw come in. My chat didn't stay up very long, and I can't. I'm just having trouble with my controls here. So if it's something other than 19, please chat that in. I believe that's what I saw though. Okay, that came up. Okay, thank you. All right, so let's get to number 19. All right, so we've got a Venn diagram, and we're going to have to shade it in for the set given. Now, the set given for what I have is B complement unioned with A complement intersected with B complement. And they give you the Venn diagram. Since we're just dealing with two sets, A and B, so two circles. Set A, set B. All right. So the way you want to approach this is if you have just two sets you're dealing with inside the universal set, that is going to separate the Venn diagram into 4 regions. And so you're not saying how many belong to each region, you're just numbering the regions, 1, 2, 3, and 4. And we're going to use those, what we know about set operations, to figure out what numbered regions I should shade in. So what I'm going to do is I'll say, well, B complement. Well, first I'm going to look at this right here, and I recognize that as De Morgan's law. And so I'm actually going to rewrite that first as A union B, and then take the complement of that. So if you do it this way, which can be done, it takes 3 steps. This takes 2 steps. So just being a little more efficient. All right. Now I can figure out what B complement is. It's everything outside of B, so it's going to comprise regions 1 and 2. And so I'll just put B complement is regions 1 and 2. Then I'll figure out A union B. That's got to be an A or B. And so that would be regions 2, 3, and 4. Now, if you take the complement of that, that's everything outside of those regions. So that would be just region 1, which then gets me to a point. It says union. Remember, you throw everything together. So that would be 1 and 2 combined with 1. So it's 1 and 2. If it had said intersection, if this had been an upside down U, I would have said just 1. And so then it's just a matter of shading everything outside, and then also region 2. So on my math lab, once you've done this work, you know what to shade. Take your cursor, left click inside the Venn diagram, you'll get a toolbar, and you have what looks like a paint tool on that horizontal toolbar at the bottom. If you scroll over it, it says region shading tool. You click that and you move the paint tool to, and you know what 2 regions you want, and you have to do them one at a time. So I come back, click the shade tool again, hit 2. Now I've got it all shaded, and just hit check answer. Any questions on 19? Another question, another problem. All right. Okay. Anything else out of 2.3? All right, if not, we are going to talk about 2.4 today. Turn the page. All right, so this first thing I'm going to discuss was actually touched upon in the exercises of 2.3. And we talked about it a little bit last class, but I'm going to go over it one more time. We call it the cardinal number formula. It simply says this: cardinality of A union B for any 2 sets A and B is equal to the cardinality of A, the number of elements in A, plus the number of elements in B. Now, this would work as long as A and B don't have anything in common. That is, their intersection is empty. However, if there is something in their intersection, A and B have something in common, what ends up happening on this right side of this equation is you end up counting the element twice, and this equation won't balance. So to cover all bases, we'll subtract out the number of elements that are common, and that balances out the equation. So this will work for any two sets A and B. You're going to have some problems in the homework of 2.4 where they give you threes. Notice there are basically four parts. There's three on this side, one on this side. They'll give you actual numbers. One piece will be missing, and you end up solving a linear equation to figure out the missing part. I don't know, there's 3 or 4 problems like that, dealing with that cardinal number formula. So what we really want to turn our attention to today are what we call survey problems. And they're going to come in a couple variety of forms. One, just listing out cardinalities. And then 2, actual kind of applied problems. And give me 1 second. All right, sorry about that. My dryer was making a big old racket. Okay, survey problems. So what I want to do is actually find a problem. That you'll see in the homework, and as an example, and work it out. So we're going to do this one. So example. All right, so I've got to write down a bunch of information here real quick to do the problem. We're going to have 3 sets we're dealing with. We're given the cardinalities of a bunch of sets. We're going to have cardinality of A is 57. Cardinality of A intersect B is going to be 35. Cardinality of A union B is going to be given to be 81. Cardinality of A intersect B intersect C is going to be 15. Cardinality of A intersect C is going to be 21. Cardinality of B intersect C, 25. Cardinality of C is going to be 49. And the cardinality of B complement is going to be 52. Double check on the numbers. I think we're all good. All right. So what our objective is going to be, whether the information is presented like this or in words and like an applied problem, which we're going to look at next. We want to use a Venn diagram to separate out the numbers in all the possible regions. Now, first off, we decide how many sets are we working with within the universals, and it's 3. We've got a set A, a set B, and a set C. So we'll draw a Venn diagram. So we'll label the sets A, B, and C. Now, if you have a Venn diagram and it has just a universal set, and this follows every time, then there's one region. If you have one set in that Venn diagram, then you actually have two regions here and here. You have a Venn diagram with just two sets, which we looked at earlier. You have two interlocking circles. There are four regions, 1, 2, 3, 4. If you have three sets in here, note you've got 1, 2, 3, 4, 5, 6, 7, 8. It's powers of 2. If you put 4 sets in there, you'll have 16 regions. If you put 5 sets in there, you'll have 32 regions, so on and so forth. It's always by powers of 2. Now, 4 sets, which we'll look at a little bit next time. It gets pretty squirrely because you can't use 4 circles. You have to use some other shapes in order to get all the regions required. But 3 is not too bad. And all the problems you'll be looking at here in 2.4, none of them will be more than 3 sets. But our goal is using this information here of cardinalities to put into each region how many belong to that particular region. And you'll note that you're given 8 pieces of information here, and there are 8 regions. So you always, when you're starting a problem, a survey problem like this, start where all 3 overlap, which would be right here. And that will be given right here. Notice A and B and C, the elements that are in all 3 simultaneously. Says that it is 15. 15. And I'll check. I've used that piece of information. Then, and there's no right or wrong at where you go from there, but I go to these regions. I consider them next, and I just pick one. Notice I've got A intersect B. That is elements that are in A and B, and it says it's 35. Now, this is where you start to separate out the numbers. A intersect B, notice, is all of this. So what we're saying is we've already counted 15 of them. They are in A intersect B. So what I need here is whatever number plus 15 that gives me that total of 35. Or you can just think of it as 35 minus the 15 we've already counted. Either way, there's got to be 20 right there. Does everyone see that? Why it's 20? It's that piece of information. All right, move on. I'll go down to here. I see A intersects C. That's what's common to A and C. It's these two. So it says it's got to be 21, again, which we have counted 15. So I would need 6 more to get my total of 21. And then I see B intersects C. It says it's 25. That's here. So I would need 10 more for that total of 25. Questions thus far? Okay, if not, we're going to move on. Notice there are 4 pieces of information left and 4 regions left to find. I'm going to go to this one. I'm told that the A has to have 57 altogether. Now notice A is made up of 4 regions, of which I know 3. So, and that's what I need to figure out that last region. If I was still missing 2, I wouldn't be able to do this yet. But since I know 3 of the 4, if I add up 20 plus 15 plus 6, that gives me 41. And then 57 minus 41 is 16. So then now if I add up these 4 numbers inside of A, I will get my 57. I've used that Now I can go ahead and use this one. Now it says A union B is 81. That is all the regions comprising A or B. That would be 6 regions here, 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 and here, of which I know 5 of the 6. So if I add up 16 plus 20 plus 6 plus 15 plus 10 and take that away from 81, that'll give me what I need to get my total of 81. So I'm punching them up on my calculator right now real quick. 16 plus 20 plus 6 plus 15 plus 10 is 67. 81 minus 67 is 14. Use that. I'm given the cardinality of C is 49. Again, 1, 2, 3, 4. I know 3 of the 4 regions of C, so 6 plus 15 plus 10 is 31. 49 minus 31 is 18. So we need 18. Now I have 1 region left and 1 piece of information left. It's outside of all 3 sets. So what I'm told is cardinality of B complement is 52. Now that is everything outside of B. Everything outside of B is 4 regions, here, 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 and here. So if I add up these 3, 16 plus 6 plus 18, I get, looks to be 40. So if I take that away from 52, that would give me 12. And it is complete. Any questions on this one? All right. If not, let's look at another type of survey problem. It is one of my all-time favorites to read. We good to turn the page. All right, yell at me if I need to turn back. I'm going to turn the page. So we're going to do another example. This one's going to be in words, not with set notation. But we're going to do the same thing. In terms of, we're going to have 3 sets, and we're going to figure out how many belong to each region of the 8 of all the total of 8 regions, just as we did. All right. And I'm not, this problem has been in this book since like the 3rd edition. And again, we're using like, I think it's the 14th edition now. It still cracks me up. Now, I'm not picking on any genre of music here. I actually love all genres. Growing up as a kid, my mom was a rock and roller and my dad was a country music person. So I got basically everything. I can remember mom, as a little tiny guy playing Pink Floyd's Dark Side of the Moon right when it came out, because I'm old as dirt. And that evening watching Porter Wagner on TV. So I loved it all. But anyway, that said, there's a radio station. They do a survey. And it was once said that country music, or country western music, has 3 basic themes: love, prison, and trucks. So radio station does a survey, and it produces the following data. So here's the data we're going to work with. 12 songs about a truck driver who's in love while in prison. 13 about a prisoner in love. 28 about a person in love. 18 about a truck driver in love. 3 about a truck driver in prison who's not in love. 2 about people in prison who are not in love and do not drive trucks. 8 about people who are out of prison, are not in love, and do not drive trucks. And 16 about a truck drivers who are not in prison. First question is asked, how many songs were surveyed? Now, if you go and add up all those numbers, the 12, 13, 28, 18, 3, 2, and 8, and 16, you're going to have way more songs than were actually surveyed. And the problem is there's the overlap in the sets. And so we're going to use a Venn diagram, just like the last problem, to separate it out. Now, if we were back in the classroom, I would have this shown up on the screen. I wouldn't have to write all this down. But we are not. We are out here in the virtual world. So what I'm going to quickly do is, and try to shorthand it as best I can, still not losing the information. I'm going to jot that down so we've got it to reference. So that's what I'm going to do now. So we've got 12 songs. About, and I'm going to go TD truck driver. Who is in love while in prison? We got 13 about a prisoner in love. 28 about a person in love. 18 about a truck driver, I abbreviated that, in love. 3 about a truck driver in prison. Not in love. 2 about people in prison. Not in love. And don't drive trucks. And you have 2 more. 8 about people not in prison, not in love.
Seems more comfortable just walking my head. Did you just feel really cool, dude?
Trucks.
Love you.
And 16 about truck drivers who are not in prison.
There's more hints.
All right. So notice there are 8 pieces of information given. And all right. Got 8 pieces of information. So we're going to draw a Venn diagram of 3 sets. So make my box. And circle. 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 All right. So I'll label this, there's no right or wrong here, but we have 3 sets: people in love, people in prison, people who drive trucks. Okay, so here we go. We're going to fill in all 8 regions. We're going to start just like we did before. And so somewhere we're going to have a piece of information that tells me how many people belong to all 3 sets. And it's right at the get-go. Songs about a truck driver who is in love while in prison. And it says there's 12 of them. So into that region, I put 12. And I've used that piece of information. Okay. And then onward and forward. If I go to the second piece of information here, it says 13 about a prisoner in love. So that's the intersection of P and T here. And this is where we begin to separate it out. Because it's all of this. So what it says is I have already counted 12 of the 13. And that means I would need 1 more. Are we okay there?
Mr. Cunningham, would it not be above the 12?
It sure would. Thank you very much. I'm not sure who said that. Because I can't see everybody in over in there. I just heard the voice. Thank you. It's L and P, prisoner in love, and I labeled them. And I did this problem yesterday, and I probably had those 2 reversed in them anyway. My bad. That should be a 1 right there. This set's L and P, prisoner in love. Thank you. All right. So aside from my mistake there, are we good? Okay, so now next piece of information is about a person in love, which is here. So that's where I was getting at. I don't have enough yet in order to use this because L in any one set in there in a 3 set situation will have 4 regions. So I only know 2 of the 4. I need to know 3 of the 4 in order to use it. So I'll just move on. And I've got 18 songs about a truck driver in love. So that's L and T. That's these 2 sets, and that's right here. So if it's 18 and I have counted 12, I would need 6 more. So I've used that one. All right. Go to the next piece. The next piece says there are 3 about a truck driver in prison who is not in love. So, a truck driver in prison who is not in love. So here's one where I don't have to do any subtraction. It's actually telling me what belongs to this region right here. Has to be in the set P, has to be in the set T because it's a truck driver in prison, but it has to be outside of the set L. And so that is this region and this region only. And so that is 3. Are we good there? All right. So now we got 2 songs about people in prison who are not in love and don't drive trucks. So that got to be in the set P, but they got to be outside of the set L and the set T. So it's just, they're describing this region only. And so that is 2. And I've used that. Okay. 3 pieces of information left and 3 regions left. I've got 8 about people not in prison, not in love, and don't drive trucks. That's outside of all 3 sets. That's this region, and that is 8. So I've done that one. So if I go here about a truck driver, truck drivers who are not in prison. So notice that is 2 regions. That's here and here. Truck drivers who are not in prison. It says it's 16. So I've already counted 6 of them. So that would give me 10 to get my total of 16 that are in T, but outside of P. And now I go back and I can use this one. 28 about a person in love, and that is inside the set L. And I know 3 of the 4. So 6 and 1 is 7 plus 12 is 19. And so if that's 19, 28 minus 19 would be what, 9? 28 minus, what did we just say? 19. And that would be 9. And I have all my regions accounted for. Questions on this one? Okay, so when you're working these kinds of problems on my math lab, they'll come in kind of first 2 ways. Some of them, they'll just give you a Venn diagram, and what they do is have a blank square field into each region, which you have to punch the number in. And so in which case you work it out on paper like this, then you put all the numbers in, then you hit check answer. The other way is multiple choice. They'll give you several Venn diagrams which to choose from that already have the numbers in them. But even then, you're still going to work the problem first, and then, you know, to know which one to choose. And some of them will ask them, once you get the Venn diagram constructed and checked, it'll ask some questions about it. So the answers on those questions are dependent upon your Venn diagram having the correct numbers in the regions, obviously. So as an example, a few questions like this one. First off, the very first question, maybe I'll put them down here. How many songs were surveyed? So this is where I would add up all the numbers. And I believe this adds up to 51. And that's just where I worked it yesterday, but I'm going to add them up. 8 plus 9 plus 1 plus 2 plus 6 plus 12 plus 3 plus 10. It is 51. So that's how many songs were actually surveyed. B. How many songs were just about truck drivers? And that would be 6. 6 plus 12 plus 3 plus 10, which is 31. Just everything in T. Next question, how many were about prisoners? So that would be the 4 regions comprising P. 3, 6, so 18. Adding up these 4 numbers. Truck drivers in prison. So you would have to be in the set P and the set T. So it'd be 12 plus 3 or 15. People not in prison. Last one. That would be any region outside of P, and there's 4 of those. So the 8 plus 9 is 17, plus 16, that is 6 plus 10 is 33. Any questions on that? All right, so one last type of problem you're going to see. I'm going to turn the page unless there's an objection. All right. Sometimes you encounter problems where you have multiple sets and a Venn diagram won't work because the complement of one set is not one of the other sets you're given. So such an example is I've got a problem here and you've got 3 sets representing grade levels or school levels, junior high, senior high, college. And you got 3 other sets and they're basketball positions, guard, forward, center. And so, you know, the complement of college or a grade level is not a basketball position. So a Venn diagram doesn't apply here. But what we can construct in this is what we call a contingency table. And so what I'm going to first do, is I'm going to draw this contingency table. I'm going to put the numbers in, and then we're going to ask what number belongs to each of these sets. So, and you'll have a couple problems like this on the homework. So the first thing we'll do is draw the contingency table. All right, I think I've got them off here. All right, so I'm gonna use capital letters J for, these are the grade levels: junior high, senior high, and college. These are gonna be basketball positions. Guard, forward, and center. I would like to use a C, but I already used the C here, so I'm gonna use a capital N. That's for center position, basketball position, center. All right, now I'll put the numbers in. 9, 6, 4, total of 19 on that row. 12, 5, 9, 26, total for that row. 5, 8, 2, 15 for that row. 26, 19, these are the total for the columns, and 15. And if I add up this row or add up this column, I get the same total of 60. So we have 60 total basketball players at varying levels, scholastic levels. All right. We're going to use this table to find the cardinalities of a bunch of sets. All right, so here we go. We'll start easy. So we want the cardinality, our first one, of J intersect G. Now, one thing I want to be able to do is I want to be able to express this in words. Remember, intersection translates as and. So I want them in both sets, this and this. So I want to know the number of players who are in junior high and play the position of guard. And that's right here, these 9. So that is it. Questions on that? Do another one like that. Cardinality of S intersect N. So this would be the number of people who are in senior high and play the position of center. And it is also, it's different 9, but it's these 9. All right. And C. All right, so let's up the ante a little bit. Let's find the cardinality of N unioned with S intersect F. All right, so first I'm just going to express it in words. We want to know the number of people who play the position of center or are in senior high and play the position of forward. So first off, as long as there's, because this is union or, and we've seen from the very beginning of class that we call cardinal number formula, as long as there's no nothing in common between the two sets I'm unioning up, I can just find the cardinality of each and add them up. And that's what's going to happen here. So that is the number of people who play center is easy enough. It's 15. The number of people who are in senior high and play forward is just this 5. Notice there's no overlap. So it's basically at the end of the day, that 5 plus these 15. Or that's a total of 20. Questions on that? All right, let's do another. S, we're going to find the cardinality of S complement intersected with G unioned N. All right. Let's see what we can come up with. So in words first, this is the number of people who are not in senior high, and they also play the position of guard or center. So if you're not in senior high, then you are in what, junior high or college. So you're here or you're here. Now I want, so kind of thinking of a line drawn here and a line drawn here. I want to have the people overlapping with that are guards or centers. I'm going to put a check mark. That would be here, 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 and here. So you're not an S. You got to be here and here, overlapping with your guard and a what? Center or a center. And so it's going to be 9 plus 4 plus 5 plus 2, which would be also 20. Questions on that? Get rid of my check marks here. All right. Let's do another one. All right, so this time, let's find the number of people who are S intersected with N complement, or that is unioned with C intersect G complement. All right, so I want to know number of people who are in senior high and don't play the position of center, or are in college and do not play the position of guard. All right. So as long as these two, we can find out the number of people here and the number of people here, and as long as there's no overlap, I can just add the two together. So let's just figure out how many people are in senior high and don't play the position of center. Well, so you got to be in senior high and you're not playing center. That means you're guard or forward. So you're these two. That is 17. Now, college and not a guard are these two. And that's 10. And 17 plus 10 somewhere is 27. Questions on that contingency table? All right.
I have a question.
Yes.
So with this contingency table, will there not be any of them that overlap?
Generally
Because-
not, because
Okay.
because of the way they are what separated out, but it is still possible. I'm not saying it's not impossible. That there may be a situation where they would overlap. I don't have one per se in this example.
Okay.
But in which case you would just make sure you would subtract them out. That is, don't count them twice. So look, I got one more here. Let me look at it real quick and see. Let's just do one more and see if that might happen here. So one more. In complement intersected with S complement intersected with C complement. All right, so I got complements all over the place. What I'm going to do on this one, notice these are both intersections and these are all complements. We can actually hit this with the Morgan's law. That is, I could view this as simply N union with S, union with C, and take the complement of all that. It would be the same thing. All right. Let me get rid of these. All right. And I'm not sure which way would be. So we've got first S, the union of S, C, and N. So here we're looking, so I'm looking at this one right here, and I can already see there might be some overlap, but then again, I've got the complement thrown in here. So that may complicate it. This may be I'm going to go up and just look at it this way. So let's do it this way. We're looking for the overlap of these three. Now, if you're not in N, you are what? A guard and a forward. So what I'm going to do is I'm going to kind of draw a line. You're here and you're here. If you're not playing center. If you're not in senior high, you are here and here. All right. And also not in college. That puts you what? Here and then here again. And it would appear you need the overlap, not the senior high. You need that almost double overlap. Here, 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 and here. And that gives you here, 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 and here. And that comes up to be what's 15, 20, 32. Of course, I don't have an annotated book, so I'm not sure. I was verifying, but I believe I've got it. But I really didn't have to subtract anything out per se, but there's definitely a little bit of overlap on this last one. If I look at Yeah, I'm not really seeing where I'm having to subtract out. But this one's a little bit more difficult to do this way, though you can write it that way. This was about the best way to get at it here. And what I did again, I said, okay, if you're not in a center, you're here and here. And I drew the two lines kind of coming down like that. And then if you're not in senior high, you're here and you're here. And if you're not in college, you're here and you're here actually. And that was my bad. I had too many here. It's actually just 6 + 9 or 15. So I'm going to work that because I know that was really confusing. Let's see if I can get rid of all my marks and then rework it. All right, so one last time. So looking at it this way, if you're not in senior high, you are a guard or forward. So you're here and here. And I think I'll put a little X this time. So that is just to say you're not a center. If you are not in senior high, then you are in junior high or you are in college. And if you're not in college, you are in junior high or senior high. And what I'm looking for are the ones with 3 X's. That is where all 3 overlap. And so it's just these two right here. And so the 6 + 9 is 15. Are we okay with that? Now, if we would look at it this way, let's see if I can do it that way. 26 plus 15. Yeah. Okay. So if I were to look at it this way, I gotta still get 15. If I add up the number of centers, so that is I'm working inside here, there's 15. Now notice there's 26 and what 15 what people in senior high and college. So if you go 26 plus 15, I don't want to add in. So I added this plus this. This is where you would actually subtract where, counting overlap. So you add these two, that's 26 plus 15. Now the number of centers is what, 15, but you've already counted the 9 and 2. So I would only add in the 4 or subtract these out if you want. But then if you add up plus 4, you get 45. But then you'd want the complement of that. So that would be, you had a total of 60. So you want the other 15. Does that make sense? So there, that last one had a little bit of overlap to consider. So, all right. Are there any other questions? All right. So on homework, 2.4. Signing that. Today is the 13th, so I will make that due on the 18th, our next class. And so 2.4 is now assigned. On Monday, I do have some other kind of loose ends I want to tie up dealing with infinite sets. And we're going to review. I'm going to assign a quiz that is basically kind of a review quiz for the test that I then will assign. And so we will be wrapping things up for set theory on Monday. And we'll look to move on to numeration and number theory, which is our next unit. All right, could somebody, again, for some reason, I cannot grab my controls here. I've lost my cancel share. Can't get rid of this thing. Somebody, just doesn't matter. Just type in a chat. Just hit a letter randomly. I don't care, any one of you. There we go. So at least got that. Son of a gun. I have to figure out. I'm still not sure what's going on here. Well, gang, it's all I've got. I can't end the session right now. I can't get a hold of the button to end the session, but or I can't even pause the recording. So the end of this recording is going to be me just struggling with my controls. But I will upload this and get this paper. It is in the paper is due the last regularly scheduled class meeting of the semester before finals week. I don't know the specific date right now without looking at the calendar, but it's the last week of classes before finals week. So that puts us basically the week after Thanksgiving is what I would say. We usually have a week, 1 week after Thanksgiving before finals week. Maybe we have 2 this year. I guess maybe we possibly have 2. I'm not sure. I'll have to look at the calendar. But it's the last regularly scheduled class meeting. So the last Wednesday that we meet before finals week. And otherwise, you guys are free to go, and I'll figure out my control issues here as soon as I can. So talk at you all later, and have a safe weekend, and we'll see you on Monday.